Fixate on Code, Episode 5. Alright, Larry Buerta here, and you're listening to Fixate on Code, the weekly bite-sized podcast where I talk to the best devs about their favorite strategies for writing great code. Now, let's chat with today's featured guest, Amjad Masad. Amjad, are you ready to get down to business?
Definitely ready.
Amjad is the CEO and founder of Replid, a simple and reliable cloud coding interface supporting more than 30 languages, built to assist teachers in the classroom and make prototyping painless for software engineers. Amjad was also tech lead on the JavaScript infrastructure team at Facebook, worked at Codecademy at its founding stages, and even spent some time at Yahoo before that. On top of that, Amjad is also a core contributor to Babel.js and React Native. Amjad, can you fill in some of the gaps in that intro and tell me a little bit about what you get up to when you're not writing code?
Yeah, I think that was a perfect intro. I guess some of the gaps. I am from Jordan. That's where I grew up, and I studied computer science. And then where I worked at Yahoo before joining Codecademy and moving to New York. I'm currently in San Francisco, where the HQ of Replid is. When I'm not writing code, we're let's see. Well, it's been since we started the company a year ago. It's been taking, if not the majority, all of my time. So if I'm not writing code, I'm replying to emails and talking to users, doing administrative stuff that comes with the CEO job, like doing payroll, accounting, things like that. Chores, basically, in order to run the business. But, sometimes you have to do these things in order to actually do the thing that you want to do in the world.
Yeah, some of the necessary evils. Now, Amjad, you've worked at a number of big companies that would make a lot of people jealous. What were the steps that got you to where you are at now, to being CEO of Replid?
Yeah, so I think the main thing is to always be thinking about like what you want to build next, whether it's at your work or whether in your side project. And the way to think about that is there are a couple of strategies that I use, but one is try to predict what's an upcoming technology. So for example, if you want to be known in a certain community, if you want to have some expertise and be an authority in a say a language community, the best way to do it is be there on the ground level. And we're lucky in our industry. There's always a ground level around. So if you right now look around you, you'll see multiple new languages. You'll see multiple new frameworks. So pick one of them. Try to predict it. It's like investing. Try to figure out which one has the most legs. But even if you failed at predicting that one would be successful, you'd also still have a good time. But that's the first step. So look for a language that doesn't have a lot of people, but has a really core community of people that are pushing it forward, that are passionate about it, that have experience, and that are welcoming, so that you can come into that community and actually contribute and do something with it. So that's one. And then the second is, build cool stuff. I mean, just find the technologies that you want to learn, and then find the useful things that you want to build, and then combine the two things together, and you have a really winning recipe. So Replid came from the problem of how hard it is to get started with programming. I was in school, and every time I'd go to a new programming class, I have to install my IDE, my compiler, and then the next class I'd have to do the same thing all over again. So the problem was let's make coding in the browser easy, or possible at least. And then the other thing, I was really interested in JavaScript, really interested in HTML5, really interested in kind of pushing the envelope. Back in 2010, everyone was really pushing the envelope of the web and seeing what the web can do, and compiling different things to JavaScript. And So I wanted to be part of that. So, combining these two things, I think you would have a winning recipe. And, most of the people that end up at great positions in big companies usually come from open source work or come from the community. I mean, if you look at Facebook now, Facebook hires from the React community. I mean, for example, they just hired the guy who wrote a competitive library to React, a library called Inferno, and it was faster than React. And they hired the guy. That was just recently. That's one example off the top of my head, to make React faster. So the best way to get to the big companies and the important teams is actually not through the front door. It's actually through the back door.
And open source projects are only one way to get noticed. There's tons of people who are, I suppose, they're getting their name out there teaching, whether it's from courses, writing, or presenting at conferences. Now, Amjad, can you tell me about the worst experience you've ever had on a project?
The worst experience. I mean, so there are experiences that are bad that looking back on them, they're rewarding and they're important to have had. I'm not sure. So let's see. I mean, working on product at Facebook was a bit hard because so when I joined Facebook, before moving to the infrastructure team and working on React Native and Babel and these things, I worked on Photos team. And I like working in product. I don't have anything against it. The problem is the Photos team at Facebook was kind of one of the oldest teams and one of the more kind of cemented products, and it was generating a lot of revenue and it was really hard to change. So I ended up prototyping and working on a lot of different products that didn't make it out. And that's always, a lot of engineers will probably relate to that. That's always disappointing to go through. But when you look back at it, you're you can see the concrete learning lessons that you had. Well, sometimes actually the lessons are negative, or you would say, okay, I know not to do that. I know when I start a company, I don't want to get my product in a position where engineers can't change it. For example, it could be that kind of learning experience.
And I know working on projects that don't make it into the world, it's super frustrating, but still it's that experience that you draw on for future projects. It's easy to forget where you've come from and the perspective you've gained. Now, Amjad, do you have any methods, tools, or services that you're using on a daily basis that you'd hate to be without?
I'm trying to think beyond the usual typical stuff that any engineer would say or any developer would say, which is, my editor. I love Emacs, and I'm very productive in Emacs because I can just be focused on a single screen and do most of the things that I need in just one screen. I actually love Chrome developer tools. When working with a big product like Facebook, you don't understand you don't understand most of the code. That's by definition almost, because most of the code is not written by you. Most of the code is not designed by you. Most of the code is written over years, and there's no single designer. It's kind of innovation over the years, and hard to understand, not very documented. So Chrome DevTools in that scenario really helped me out to figure out that code. And I even wrote a few extensions. Some of them still around, some of them are not, to help me do that. So one of the first extension was called Flow. So I know Facebook has a Flow type system, but that's not that. Mine is Flow without the W, so FLO. And so what Flow does is it does hot reloading. So one of the problems is that when you're doing local development at Facebook, the reload times are really slow. But even if they're not slow, once you get to the flow that you want to get to, it takes time. Say I was working on the album upload flow. So every time I change something in album upload flow, I need to write the code, save it, and then go to the browser, refresh it, and then take a photo, upload it, and then get to the album upload flow. So like that feedback cycle is not the same as what we're used to with Command R or Control R. That's the web feedback cycle that we're used to. So I wanted something to like, as I change the code, to like update it immediately. So luckily Chrome API has a method to like pull in and replace certain files and styles live on your page. But actually nobody made a good use of that. The only thing that made a good use of that is actually the Chrome DevTools source tab. So you can change code live in the Chrome DevTools, but they also exposed that API. So I used it to do that. So when I had save, what happens is there's a WebSocket connection between my browser, my Chrome extension, and my server, and the server is watching the files. So when I hit save, it detects what file changes, it transforms it, whether it's Babel or what have you, and then sends it down to the client. And then the client, which is the Chrome extension, would look up where that file is and would swap it out. And that was, before React Hot Loader, before hot loading was a big topic. I was trying to do this kind of stuff. It worked really, really well, especially in the context of Facebook. It did not, however, become very popular because setting it up required quite a bit of investment, and it wasn't easy to do that. So that's one of the tools.
So how does Flow differ from what we have now with HMR and Live Reload and those sort of tools? Are these tools similar to Flow or a modern evolution of Flow?
In some sense, they're better than Flow because they integrate with Webpack, with your packager. So you don't have to write the custom code to find the files. You don't have to write the custom code to replace the files and things like that. So they integrate well with the rest of the tool chain. That's one, and I think that's the biggest one. But what Flow was better at is that it hooked into the native. The second thing is like they work with any browser. Flow kind of just worked with Chrome. But what Flow was better at is that it actually hooked into the engine API. So now with HMR, there are some edge cases where, say, you have an event listener, right? So you have window dot on key press, and then you pass it a function. That function, that piece of code with HMR would not be replaced because that function is a compiled function, and the browser has a pointer to that function, and you can't replace it. It's just in memory. So it has a lot of edge cases like that. Now, what Flow does actually recompiles the code of that function. It would like, you have an event listener, you had a set interval, you had a timer. All these things will update. So I think that's the thing that people kind of like take for granted when they're looking at these things. That was hard to market because people didn't get why that was important. But for us to have a really good hot reloading system is for us to really hook into the native APIs. I think that's why Dan Abramov, for example, one of his inspiration for building Redux is to get hot reloading and time travel to work on a fundamental level in React. And so JavaScript doesn't lend itself to these kind of debugging tools, right? Because it's imperative, it's very mutative. So you either need to like reinvent things from scratch or invent a framework that makes all these things easier, or just circumvent all that and go to the engine itself. And I try to do the latter.
Yeah, it's incredible how just a few years ago that things like hot module reloading were mostly unknown. And today these are just standard in our workflows. I mean, there was so much obstruction in our feedback loops that just isn't there anymore. Now, regarding frustration in your daily work, where do you feel there's room for things to be done in a more effective way?
God, there's so many. Um, yeah, it's never perfect, and we reach homeostasis pretty quickly, and we want it faster and faster. So one is Webpack. I think Webpack is a great product, but it's slow. It's so slow. It's just it's bringing us back to like compiled code. Like, I've seen apps that spend 45 seconds per file save,
Wow.
just to get something on the screen. I've seen apps that spend,
I've been there.
yeah. I mean, yeah, you don't even have to have a massive code base to get there. So I think Webpack can be improved dramatically. So at Facebook, I worked on the React Native packager. And with React Native, our goal was to be less than 100 milliseconds for turnaround. For any time you save a file, it should reload and it should recompute the bundle in less than 100 milliseconds. We were able to achieve that. I'm not sure if now React.
How much code were you guys compiling?
We had hundreds of megabytes of JavaScript. I think the compile bundle
in
was
less than 100 milliseconds.
Yeah, I think the compile bundle was 10 megabytes, something like that.
Wow.
Yeah, so it was a lot of code.
That is fast.
Yeah, so we had to do a lot of crazy things. We had to compute I had to do a lot of hacks to like recompute, for example, the source maps. So for example, we changed Babel to retain lines. So for example, Babel, munges your code in ways that you can't imagine. But actually there's a little known option called retain lines. So retain lines, what it do is like, it will do the best effort to keep the compiled code matching the original code in the same line. So what that gives us is it makes it very easy to generate the source map. So source map generation, for example, took like, it's one of the hardest thing that actually Webpack has to deal with. But for us, it took something like, 30, 40 milliseconds to like generate the entire source maps and concatenate it together. So that sort of things. Like we had to do a lot of things by hand. I know the React Native packager team now at Facebook, they're not only doing that, they're actually looking at the compiled. They're looking at V8's JIT, and they're looking at the assembly code from the JIT and like figuring out how they can make things faster. And they made source map generation even faster now. So that focus on performance, I'd love to see it in Webpack. Or maybe I'd love to see the React Native packager becomes a general purpose packager, because I think it's a pretty good technology.
Yeah, it sounds like something everyone can benefit from. I don't think there are any Webpack users out there who can't relate to the frustration of waiting for bundles to compile.
Yeah.
Now, in terms of new projects, libraries, and frameworks, what are you most excited about at the moment?
Let's see. React is still pretty exciting. A lot is happening in React. I was at ReactConf yesterday, and they announced React Fiber. So React Fiber is a rewrite of React internals, and it just it wouldn't necessarily change the API, but it just would make most apps a lot faster. So it's really exciting to see. I'm not an expert on Fiber, but it's really exciting to see like what's happening in the React community. I think it's still, where the most of the innovation in the front end is happening, and they're always trying to outdo themselves. They have this new language called Reason that they talked about as well. That actually they write React in. You can write React in Reason. It's based on OCaml, and it compiles either to native, so you can run it in React Native, or a native mobile app, or it compiles to JavaScript. I think now they have 10% of Messenger written in Reason and React Reason. So you see Facebook always, the community sometimes get mad because they're like, oh, I have to learn one more thing now from Facebook. GraphQL, it's still early days of innovation. So I think this whole React ecosystem is still really interesting. Another one is I personally love Go. I think it's more like stabilizing the Go language, but there are still unsolved problems there. There are dependencies that they're trying to solve, but it's still an exciting frontier. Go and Rust as languages, I think, are exciting new frontiers because language design was stagnating for so long. It was all the same set of features that people are putting in different ways. CoffeeScript is Ruby and Python and JavaScript put together. It's like everyone's just picking and choosing different language paradigms and creating creating a mixture of them. But I think Go and Rust are trying to do something new. So I think that those are exciting as well. Oh, and if I can add one more thing, I think what's happening in the kind of what's been dubbed the Web3, which is the distributed web. I think this is really exciting for me. To name a few projects, there's IPFS. There is, of course, Ethereum, and to Bitcoin a little bit, but I think it doesn't really solve the problem. I think Ethereum as an application platform, as a distributed application platform, is interesting. There's a project called Orbit, and that's really interesting as well. And what all these projects are trying to solve is centralization. And I think Tim Berners-Lee recently also threw in with the effort, and they said that yes, the web is broken basically because it's too centralized. AWS went down; it broke the internet a couple of weeks ago. So yeah, we're in a terrible place. I mean, if you think back to like the inventors of the internet, when they invented TCP/IP, they had in mind that they wanted the internet to work in the case of a nuclear war. That's how distributed at the core the internet is. But now we're building all these services that centralizes everything in a single place. And so there's a lot of innovation that's happening in that space. So it goes back to initially you asked me like what's the best way to get your name out there or build up expertise to be hired by big companies or be part of something exciting. I think once you look at, for example, the distributed web that's happening between all these projects, I'll probably, if I had time, I'll probably go mess around with one of these projects because I'm pretty sure that a lot of people, especially with all these leaks and security issues, a lot of people kind of understand that we're trending towards technological dystopia. So we want to turn things around and make it better for everyone.
Okay, so you've mentioned Web3, you've mentioned Go and Rust and all these new languages and these specifications that are coming out. But how do you make time to learn, and how do you decide on what you actually want to learn?
So I take I think a different approach than most people in the sense that I don't learn anything until I have a project, because I just don't have patience to sit down with a book and just read. If I sit down with a book and read, all I think is about projects that I want to build with the things that I'm reading about. So, I think as I grow a bit older, I think it becomes easier for me to actually read about things before trying them out. But 5-6 years ago, I couldn't be bothered. I immediately looked at the website, looked at the documentation, getting started. All right, download, get started, and then I'll learn as I go and make mistakes and things like that. So the first thing that I do is really think about a project. Right now, I want to mess around with TensorFlow and the new machine learning and deep learning things, but I don't do it because I don't have a project. I mean, I would not see the point. I would not have enough attention span or enough motivation to just sit down and learn without actually having a project. So we're thinking about different projects at Replid that we have more and more data going through our system. So there are some exciting things that we can do there. So once we actually have some concrete plans, I'll probably take a month to start at the same time learning and planning or writing some code for what would become the project that we're gonna build.
So, with all your learning and your years of experience and the companies you've worked with, which specific aspect about programming has dramatically changed the way that you think about and write code?
I think the biggest one is concurrency. So coming to JavaScript was so I came from PHP in school, Java, C++, and before that I did Visual Basic, and all these are like blocking synchronous code. So when I came to JavaScript from that, it was a completely change of ways of doing things. I was for a while I had a consistent headache trying to understand all the callbacks, and that was tough. Yeah, and then Node came out, and
And
just
building your sideways Christmas trees.
Yeah, exactly. And Node came out, and we had what was it called, the callback doom, or callback hell.
Yeah, callback hell.
Callback hell. So so started thinking more. At first, I was really excited by how JavaScript does things. I think it was really cool. I mean, the run to completion model is really cool. Like, you don't have to think about threads. You just write a code in a single thread and make sure it just runs fast. There's nothing in your code can run and interfere with the current object that you currently have. So all these things were really cool about JavaScript. I think when Node came out, it kind of stressed that asynchronous nature a little bit more, and callbacks became really, really painful. So I started thinking a lot about callbacks. And at Code Academy, we built a lot of Node services, and we had a lot of problems with callbacks and that being called, memory leaks because of callbacks will retain the closure, and we don't know where they go. It was very tough. So that's one. At Facebook, we also, with the album upload manager, we had a lot of bugs, and 90% of them came down to concurrency. The concurrency patterns in JavaScript are just bad. So that's something that I thought about a lot. And that's why I'm attracted to Go, because Go brings an interesting, new, refreshing idea to concurrency, namely channels. So channels are these objects that can communicate with each other via message passing. And you can start these things called Go routines. And Go routines are basically functions that are potentially running in different threads, but could be running on the same core. Conceptually, they're these functions that are running on their own. And they communicate with each other via these channels. So that's a refreshing idea in concurrency, and that makes it a lot easier. It's easier than threads because you don't have to share memory. You don't have to, have mutexes, and you don't know who's holding the lock and things like that. All the problems with the mutexes, but also it doesn't suffer from the things that, say, JavaScript suffers from. It definitely doesn't suffer from the things that Python or Ruby suffers from, which is a global interpreter lock. These languages have threads, but they don't do anything because you can't really run things concurrently. So it's better than JavaScript because it's just a primitive inside the language that supports concurrency. Now, what happened in JavaScript since callbacks was promises, and promises had a lot of drama, but I'm glad it eventually won because it's much better than JavaScript. One example is say I pass you a callback. So that callback that I pass you, you can do whatever you want with it. You can call it multiple times, you can call it 3 times, and you can mess around with my logic, right? And so I would expect that you would call the callback once you're done, but you can do whatever you want with it. In promises, on the other hand, it's it's an object that inverts that doesn't have this inversion of control. I don't give you the callback and I'll tell you just call me whenever. No, instead, I start a promise, and then I have a handle to that promise. And you can't call me multiple times. You can't, do whatever you want with the callback. So it solves some of that inversion of control problem, but still suffers from code quality problems. It's still, it's not callback hell, but it's definitely callbacks, and it's you end up in multiple different closures, and it's still ergonomically not good. So what happened after that was async await, and now we're getting somewhere in JavaScript. So async await is part of a larger thing, which in computer science is called coroutines. And the idea of coroutines is that you can conceptually block a function, but in reality, you're not really blocking the function. You are yielding somewhere else to the event loop, to some other function that continues to execute while you are conceptually blocking. So the instruction is just paused somewhere in your function, and then when your turn comes back or when something is resolved, then that function continues. And why that's good is because we're now back to the basics. We can use the native language constructs, like for example try catch. Like when we were doing callbacks and promises, we can't use try catch because things are in different because things are in different closures. If we go to async await, now we can use try catch. We can use if statements. We can just write code that looks imperative, that looks synchronous, that reads like a story. Like just any regular C-like language. So I think that's really good. And actually, by the way, even Go routines are coroutines as well. So any time a language has this feature where you can pause functions and then return to them later, that's called a coroutine. And I think that is really one of the great concurrency patterns in languages. And I'm really excited to see how async await will be changing the JavaScript community. There's still some problems with async await, but I think it's much better place where from before.
How far are we away from having full support for async and await and being able to use them without any polyfills or anything?
I think definitely by the end of the year, I think most people will be writing async await. I think V8 has it behind a flag now, so they implemented it. It's going to roll out pretty fast. I think people will be excited about it, and we'll start using it soon.
And if V8 is pushing it out, then the other browser vendors are going to feel a bit of pressure to catch up and join the bandwagon, I think.
Of course.
And with that, we've come to the end of our first segment. Amjad, I'm about to throw some quickfire questions your way. Let's do this.
All right.
What is the best advice about programming you've ever received?
The best advice about programming, I think the cliche, the MVP cliche, I think it's the best. Your cliches are cliches sometimes because they're true. So it's the best advice is always take the MVP pass at the problem and then maybe expand it later.
And just getting users onto your products quickly.
Yep.
Which personal habit do you attribute to writing better code?
I think writing better prose and writing essays and all that stuff, I think really helps a lot with the way I structure my code.
So writing literature?
Yes.
Can you go a bit deeper into that?
Yeah, I just didn't want to expand too much because of the rapid fire aspect of the segment. But
no, go for it.
Yeah, so I think the way we write our code is so there are multiple ways to think about it. One way to think about it is I'm writing code for the machine to execute, right? So I don't have to write anything that has a coherent story. behind it. It's just, things that work. And, there's some value to that. We talked about MVP, but at some point you also want to make sure that people read that code, and people could be you in the future. It doesn't have to be other people. So eventually, so the code, I think, I don't know which famous computer scientist once said, but one of them said, code is for people to read, only incidentally for machines to execute. So that's a big aspect of it. So for you to write code in a way that reads well for humans, I think you need to be able to write literature well, because that's how we think, that's how we communicate, and that's how people, learn to read. So when I'm writing code, I try to have it, seem like a story. When you write an essay, you have an introduction to the problem, and then you have, the kind of you struggle with the different aspect of a problem towards the middle, and then you propose some solution, and then you have some conclusion, right? So having that standard arc of a story inside your code, I think is a very good way for you to understand it, and for other people to understand it as well.
And no one wants to revisit a terrible story ever again.
Yes.
Amjad, if you could recommend one book on programming, what would it be and why?
I think one that had the biggest impact on me is the Pragmatic Programmer. And the reason is because it has a lot of kind of philosophical approach to teaching you how to write better code and how to collaborate with your team. And so it gives you this philosophical underpinning, although it's called the Pragmatic Programmer, but also a lot of it is pragmatic. And so it has a lot of advice that you could literally read and then go apply the next day, but it has larger advice that you would would stay with you. For example, they talk about the boiling frog problem, right? The thing is, if you put a frog in a pot and start boiling it, the frog will just stay there and die from the heat eventually, but it would not feel the heat as it increase in the pot. But if you put it in a hot pot, it will jump out immediately because it's too hot. So the idea is that we as programmers, as we're building large systems, we are the frog in the boiling pot. We are, the temperature continues to increase, meaning the entropy of the code and the bad quality of the code continues to increase. But we are in the weeds so much, and we have so much knowledge cramped in our heads that it's that we don't really notice. And sometimes you hire someone new and it's like, oh, what is this crap? It's like they give you this fresh eye over what's happening in your code. So that's one. The other one that I'd like to mention really quickly is the Mythical Man Month. And although now most of the code is most of the book is dated, right? It was written in the 70s or 80s, and it was about someone's experience writing this large OS in the 60s. So, but there are some few essays in that book that are just timeless. So one of them is No Silver Bullet. And the idea is that it seems like there's no way that we can make programming 10x better. It seems like, since we started programming, since maybe the first 10x better jump was when Grace Hopper introduced the compiler and we had higher level languages, right? But since then, we really didn't have a 10x jump in the day-to-day programming. Maybe you can say open source might have been a 10x jump. It could be, but that's not in the core of how you write code day to day. And actually, in the book says that code reuse is probably the place where we can have the most impact in terms of programmer productivity. And so that message is just amazing. And the other thing that the book goes through is like talks about how you can structure your team in different ways. So, for example, it talks about the surgical team where you have a lead who's actually writing a lot of the meat of the code, but then you have everyone else who's helping them by writing libraries for them, by writing tests for them, by etc. So I think these two books are just the books that had the most impacts on me in programming.
So who in the front-end world is doing work that really inspires you?
There are a few. Mostly the people that I think about are the people that are building the libraries and the frameworks and the compilers and the tools. So Sebastian McKenzie, he's the creator of Babel and the creator of Yarn. I had the privilege of recruiting him to Facebook when I was leading the JavaScript infrastructure team, and worked with him quite a bit before I left. And I think just someone that young, being able to continue to innovate within just a span of few years, changing the JavaScript industry, right? I mean, Babel and Yarn literally changed how most people are using JavaScript. So, and he continues to do things. Like, I would not be surprised if tomorrow or next year or whatever, we're going to have another groundbreaking thing from him. So that guy continues to inspire me. And there are some people that kind of under the radar. So my friend Felix, who works at Facebook as well, he builds these really interesting tools that a lot of people use, but they don't know that he built them because he's not very, he's not very outspoken. He doesn't speak at conferences. He's not active on Twitter, but he built this thing called AST Explorer. So that allows you to paste a code and look at the AST of that code. You can also write Babel transforms. You can write code mods. And speaking of code mods, he also built the code modding library. It's the main one. I forgot what it was called, but it's the one that everyone uses now. And I think his work goes a little bit underappreciated, but I think he's also having a lot of impact. And he has a lot of interesting things in the works as well that I'm excited to see.
And there's a lot of exciting stuff coming out from some of the guys that you know personally. Now, Amjad, imagine you wake up and you have no recollection of ever having written code. With your knowledge of tools, books, and courses available today, how would you go about learning to program from scratch?
I probably, let's see. Well, depending, there are two paths. There's a path of learning online, and there's the path of finding a school. From personal experience, so I learned on my own at home, but it doesn't seem like this is the best way most people learn. It seems like the best way most people learn is with other people. So I'd find a local code school. That's the first thing that I would do. And they're popping up all over the place. Some of them are nonprofits, so you can get in somewhat cheaply. Some of them are boot camps that actually promise you to get you a job. So that's an interesting one. So I'd probably maybe do one of those. If I don't have the means to, if I'm in a remote area where we don't have boot camps, the way I'd go about it is, I'd probably first do Codecademy just to dip my foot in the water, and then I'd probably pick up a book. So pick up one of the books that has a lot of exercise in it. Exercises are great. So the book that I don't know, so that part, I don't know exactly what to say because I'm not very in tune with beginner books, but there are a lot of really interesting JavaScript books out there. So there's the Eloquent JavaScript, yes. Eloquent JavaScript is really good because it also has a lot of exercises. So I'd get that and go to an online REPL, like for example Replid, and just open the book on your side and start reading the book. And then once you see an exercise, just immediately jump and start doing the exercise. Just keep going back and forth, and I think you'll be able to learn all the basics really, really fast. Now, I think where the problem lies, and I think where we haven't done very well in the kind of the web development community, is that getting into frameworks is so hard. I think React is one of the hardest things to get into. A Create React app is awesome. I mean, it brings the barrier to entry a little bit down. I think Ember CLI, it does a great job at like guiding people through onboarding them on the ecosystem. But I think still like the web development frameworks are a little bit too complex. So, and you know, the reality is you probably can't get a job or can't be respected in the community if you don't know one of the frameworks. If you say I'm just like a native or like a vanilla JavaScript developer, like everyone will scoff at you. So there's a bit of a problem there, but I think you'll be able to get into one of these frameworks.
Yeah, and I think it's a bit unfortunate that it's those basics and fundamentals that we often take for granted, and that's what's going to allow us to pick up these new and fancy libraries all the time.
Yep.
Now, Amjad, let's wrap up with your top tip on how to work smart and the best way to connect with you.
How to work smart. I think blocking out hours of the day, like not just like 30 minutes and like going in to check Twitter, then just blocking hours and getting into flow. I think that's the best thing that I found for myself. Is actually the thing that creates the most happiness in people's lives. I mean, there's a lot of research about how getting into flow is might be the number one predictor of how happy people and how satisfied people are with their work. So get an editor that you can do most things in. So if you have Sublime and you have to keep switching screens, like between Sublime and you know the terminal, then you'll get out of flow. You need to like optimize for flow. So Emacs or opening a terminal with Tmux and Vim and everything in single screen, I think that is really conducive for, or maybe Atom has a lot of extensions, but maybe that's really conducive for getting into flow. So that's the number one thing.
And the best way to connect with you?
Best way to connect with me. I recently tried to like keep away from the Twitters, especially with the current political climate. It's just too much stuff going on that kind of like not only distracts me but puts me in a bad mood. So I would say usually I'd say Twitter, but not as much these days. I'll check it once every couple of weeks even, and sometimes not tweeting that much, but I'll probably go back to it at some point. So I'm Twitter, Masad on GitHub. But email me. I'm also happy to always respond to people and chat. So it's Amjad at Replid.
To everyone out there, you've been hanging with Amjad, Masad, and Larry Buerta. Head over to fixate.it where you'll find links and timestamps for everything we've been chatting about today. And of course, head over to Replit, spin up a REPL of your choice, and get prototyping. Amjad, thank you for sharing your journey with Fixate on Code. Keep pushing the limits and keep pushing great code.